So yesterday we were doing a few questions on Taylor series. We'll start our day today with that only. But there is a errata then that I'm telling you right now. Probably in one of the lectures, as much as I remember, I have somehow made a mistake. So sorry about that. I'm just trying to explain that mistake only. Okay. So for example, I was trying to teach you one concept that is like, let's say if I'm writing e raised to power x is equal to 100, that would imply ln 2. Okay. Or ln 100. Okay. Or if, let's say if I'm saying e raised to power e power 4, then x is equal to 4. This very much agrees for the real numbers. This very much agrees for the real numbers. Why? Because in real numbers, real analysis, what you are supposed to see that if your function is 1, 1, then fx1 is equals to fx2 would imply x1 equals to x2. So for example, if I'm saying my function is x square, so this is a many to one function. Now minus 2 ka whole square is also 4, 2 ka whole square is also 4. So what is 4? Whose map is 4? It can be square of 2 also, it can be square of minus 2 also. So here you cannot say x1 equals to x2, like 4 is equal to 4, but it may be possible that x1 is minus 2 and x2 is 2. So this kind of equality of the powers or something of this sort, you can do only if powers of probably arguments. So for example, if functions are equal, then their arguments are equal only if function is 1, 1. Okay, so this agrees in real analysis. But on that day, I made certain mistake. Let's say I was doing e raised to power z equal to 1. So here I'm doing e raised to power is equal to 1. So 1 can be many possible things. So iota 2 and pi. So here you can have e raised to power 0, you can have e raised to power iota 2 pi, you can have e raised to power iota 4 pi, so on and so forth. So in general, this is a many to one function, not 1, 1. So if I have written there 1, 1, so kindly correct that first thing. So it is a many one function because for a single value of 1, there are too many values which associate to 1. So for example, if I have on the domain set z equal to domain of definition set z equal to 0, it will also get mapped to 1. If I have iota 2 pi, it will again get mapped to 1. Iota 4 pi, it will again get back to 1. And all those values will get mapped to 1. So if I have written, I don't know exactly, but I was remembering in the morning, if I have written 1, 1, then kindly not do that because 1, 1, e raised to power x is 1, 1, e raised to power z is not 1. So this is what I have written here. So so in a persuasion to connect both the concept, I made this mistake. So kindly don't get confused by this mistake. So if I'm supposed to see that does this argument always exist that e raised to power z1 equal to e raised to power z2, does this always exist? So in general, answer is no. So what I would do to explain you this, you have to do this. So e raised to power z1 is equal to e raised to power z2. What you will do, you will simply write it as e raised to power z1 minus e raised to power z2 is equals to 1. And that will give you e raised to power z1 minus e power z2. And you can simply write it as e raised to power iota 2. Now here you will find that z1 in general is not equal to z2. Rather, it is equals to z1 is equal to z2 plus iota 2 in pi. It happens that if n equal to 0, then z1 equal to z2. So probably in a region R, this particular e raised to power z can be a 1, 1 function, but not in general. So one such region I have constructed for you. Let's see if I just take this region, that is mod z less than pi. So if I just take mod z less than pi, so my x-axis maximum I can go is pi. On y-axis again I can go maximum is pi. Beyond that I cannot. So let's say if what does this imply? It implies that z1 minus z2 can be equals to 0, it can be equals to iota 2 pi, it can be equals to iota 4 pi, so on and so. Okay. So if z1, if I'm finding z1 and z2 from this region, that is the region where mod z is less than pi, what does it imply? Any point inside this circle would satisfy this condition. That if I'm saying in this region R, all the complex numbers modulus is less than pi, then if z1 and z2 also lie, then z1 ka mod is also less than pi, and z2 ka mod is also less than pi. Yes or no? And let's say if I just write n equal to 0 and so on and so forth. So if I just write n equals to 1, so what does it imply? Iota 2 pi. z1 minus z2 is equal to iota 2 pi. That implies z1 will be equals to z2 plus iota 2 pi. So even if I take z2 as 0, comma 0, then also the Z1 will be equals to what? Then Z1 will be, even if I take Z2 as 0, comma 0, my Z1 will be what? My Z1 will be iota 2 pi. And iota 2 pi obviously would lie outside the region R. Okay. So in any case, if I'm saying mod Z is less than pi, and further e raised to power z1 is equals to e raised to power z2, then it necessarily implies that z1 equal to z2. So that is what I want to convey, that this particular function will be 1, 1 only for certain region. So one such region I've drawn. There are many such regions that I can draw also. So one such region is mod z less than pi. Yes or no? I hope this idea you might have got. Um, Bharat, any problem?
Yes, sir. Clear, sir.
है ना? So कहीं अगर लिखा हो पीछे लेक्चर में तो प्लीज डू करेक्ट इट, है ना? E raised to power x, no doubt, is a one-one function. E raised to power z, I cannot write so. It is a many-to-one function. It is not one-one function. Alpna को problem?
नहीं भैया।
Okay. चलो जी. So let us move ahead and let us start from where we were. अच्छा, उससे पहले काम करते हैं. Let us take what Bharat has given on the group. If I clearly remember, it was this question: fz is equal to root over, I think, z square minus 1 divided by root over z, and this has been asked on TFR 2020. Okay, so let us do this. I think here it was z minus iota raised power 1 over 3 or some plus iota, I don't know. Is that it was the question, and it was asked about z equal to 0, isn't it? एक मिनट दो मुझे. What was asked? एक मिनट. पूछा क्या गया? So it was asked that
How many values?
okay, so how many values does z, okay, does z take? Okay, so this was the question, I guess, right? So how many values does z take? Okay, so how many distinct values can the following function take at a given value of z? Okay, so let's say if I'm supposed to this is a question which has been asked on multi-valuedness of the function. This is what I can
Yes, sir.
right now. Okay, so as much as I can understand, this is a question that has been asked on the multi-valuedness of the function. So you just try to write it in a fashion where you can exclude z. Somehow you exclude z. Okay, somehow you exclude z. So for example, if I say z, and is that written maximum? Okay, distinct is written. Okay, so let us try to take square common. So that would give me z minus 1 upon z whole square. Okay, another part would give me z raised to power minus 1 by 4. And if you just take this also common out, you will get z power 1 over 3, and you will get 1 minus iota upon z, right? So I'll write it as 1 over z. Keep power 1 upon 3. Let us write 1 over z as zeta. So we are not interested in 1 over z because question is asked on what values does, how many values can z take? Okay, so this has become 1 over z. This has become 1 over z. So this is some zeta. I'm not interested in this right now. So this will be equal to z raised to power 1 minus 1 over 4 plus 1 over 3. And I think this will give you root over 1 minus zeta square, or whatever. So let's say, yeah, give me zeta square and 1 minus iota zeta raised to power 1 over 3. So this is some function of zeta, and where zeta is some function of 1 over w. That is 1 over z, sorry. So zeta is nothing but 1 over z. So I'm not interested here. In this region, I'm not interested because, see, here, if I was interested, then somebody would have asked me, what values does 1 over z take? Okay, so in this only, then I was interested. No doubt this is zeta, and there is a square root function here also. So it is possible, it is very much possible that at zeta equal to 0, there may be branch points here also. So at zeta equal to 0 means at z equal to infinity also. So probably, if at all, the question maker would have asked at z equal to infinity, what sort of singularities are there, then I would have been interested in this particular zone. Okay, so right now I'm not interested in this zone. Okay, so right now I'm not interested in this zone. Let us focus our attention to this zone. So what is my function? So my function is, I guess, z raised to power 3 by 4 plus 1 by 3. That would give me, I think, 10 over 12, if I'm not wrong. Kindly see. And there are some functions of zeta which I'm not interested in, right? Okay. So clearly you can see that at z equal to 0, at z equal to 0, you have a branch point. There is a branch point. Why there's a branch point? I stated on the very first day that if z raised to power alpha is there, and if alpha belongs to p over q, then in general it is a q-valued function, right? So it is a q-valued function. So for example, I have here 10 raised to power 10 divided by 12. So obviously this function is some resembles to some p over q. So this particular function will be some q-valued function. So as much as I understand, fz is a multi-valued function with how many branches? Q branches. So instead of q, you can write multi-valued function with 12 branches. So how many distinct value it can take? It can take 12 distinct values for a single point. Okay, is it clear to you? Bharat, समझ में आया?
Yes, sir. It's clear.
है ना? ठीक है. So probably this is what they've intended to ask. So that is what I keep
Right.
saying. है ना? This is what I keep saying. Actually होता क्या है, कभी कभी हम सिर्फ सोचते हैं यार ये नहीं आएगा एग्जाम. Look, there is a question. So that is why I teach कि थोड़ा थोड़ा सब पढ़ लो, बुराई नहीं है. Because any day if they are exhausted with questions, obviously they'll go somewhere here and there. हाँ जी, बोलो. Anybody has any doubt?
भैया ये हाँ भैया ये पीछे वाली टर्म्स है ना जो आपने वन बाय जीटा लिया है, तो
वन बाय
इसको
वन.
आपने कैसे इग्नोर किया है? हाँ वन बाय जीटा आपने इसको इग्नोर मतलब कैसे किया है, मतलब मेरे को ये
इग्नोर.
समझ नहीं आया
देखो, we are
क्या किया
interested in,
मतलब।
we are interested in, what all values does z take. uh, uh, so we are interested in finding uh, what is then associated uh, branches with z equal to 0, or uh, what are associate branches with z. Okay, अब हो क्या रहा है, when you're taking common out, this entire thing would become 1 by z. This entire thing would become 1 by z. This entire thing is 1 minus iota upon z. So basically you just write 1 upon z is equal to zeta. So here it is 1 minus iota zeta, 1 minus zeta square. No doubt zeta equals to plus minus 1. Here you can see they are branch points, and in fact you'll find that this particular function will be a sorry, you can say uh, will be a multi-valued function with two branches. This will happen. But about what? About zeta equal to 0. So about zeta equal to 0, this will be a multi-valued function with two branches. About zeta equals to zeta equal to 0, zeta equal to plus minus 1, this will be a multi-valued function with two branches. This particular function will be multi-valued like at zeta equals to minus iota. Sorry, at zeta equal, you can just simply see. I think this will be this. So at zeta equals to minus iota, you would have three branches. Okay, and at at zeta equal to 0, you don't have, sorry, at zeta equal to 0, you don't have any such branch points. Okay, so at zeta equal to plus minus 1, you have a branch point. At zeta equals to minus iota, also you have a branch point. But what is zeta? Zeta is 1 over z. Okay, zeta is 1 over z. So you can write zeta at, for example, if I can say that, what is zeta? So I would say that zeta would take around three values. Okay, so zeta would take three values at around minus iota. Okay, at minus iota, zeta would take three values, isn't it? देखो मेरी बात समझने की
Yes,
कोशिश.
yes,
चलो
yes.
ठीक है. Okay, at zeta equals to plus minus 1. Okay, at zeta equal to plus minus 1, I think it would take two values, because it is so for right now I'm ignoring because I'm not interested in zeta, that is I'm not interested in 1 upon z. So what sort of values 1 upon z takes, I am not interested. Even if you, let's say, if you sort of get some interest here also, let us see how many distinct values can this take. So if at z equals to, I think minus 1 upon iota, which is like iota, there are 3 branches. So at z equals to iota, there are 3 branches. Okay. So if I'm not ignoring this part, even if I'm not ignoring, because I thought at zeta equal to 0 is something else. No, sorry. So at zeta equals to, let's say, iota, there are 3 branches. At zeta is equals to plus minus 1, because zeta is equal to plus minus 1 would mean 1 upon z equal to plus minus 1. So z equal to plus minus 1, you will have 2 branches. But overall, if you find this particular function is z raised to power 10 by 12, so there are 12 branches. You can see here there are 12 branches. Yes or no?
Yes.
Okay. So if at all this particular function is multiplied with this particular f zeta, so for example, this particular f zeta when multiplied with this bigger construct, this construct has 12 branches. So overall, this particular function, this particular thing will have 12 different values for a single value of z. And this particular thing is multiplied, let it be there. I'm not interested here. So let it be multiplied with this particular thing. But overall, function, this particular function here, that is z raised to power 10 by 12, will take 12 different values for a single z. Okay. And this 12 different values, when multiplied with f zeta at all those values, would give me 12 different branches, isn't it? Overall. No doubt, I'm not saying this will not have a branch point. There will be a branch point for zeta also, but I'm just interested in saying that what sort of branches are there for z, not 1 by z. Because see, in any case, it is going to get multiplied with this. Okay, so this particular thing f zeta will be multiplied with this. This does have this particular parenthesis, or probably the bracket, initial bracket, has 12 branches at z equal to 0. And all those 12 branches, let's say if I'm placing some point r comma theta, what would happen? It will take me to e raised to power r by 12, e raised to power iota theta by 12 into something. Let it be, I'm not interested here. Let it be some zeta. Okay. Let it be some f zeta. This is one branch. Then what after one revolution? After one revolution, it will become r upon 12 e raised to power iota theta upon 6. Okay, so theta plus 2 pi. So theta plus 2 pi. So theta by 12 into e raised to power iota, I think theta by 6. Okay. So this is all in the. ऐसे करते करते, after how many branches you will return? After when it becomes what? When it becomes 12. See, are you getting my point? You're not getting my point. ये चीज समझ नहीं आ रही. देखो मेरी बात समझने की कोशिश करो. देखो. This was your function. I'm writing it in this fashion. There will be some function of zeta. There will be some function of zeta. Let's say z zeta, and this z zeta is nothing but zeta's 1 minus zeta square ka root over and 1 minus iota zeta. Why I'm not interested in this? Because this is a function of 1 by z. है ना? 1 over z. So initially I was confused that zeta equal to 0 is there. So z equal to infinity would have been asked, but that is not the case here. Let me refine it by saying that zeta is equal to plus minus 1 indeed is a branch point. And this branch point, this branch point is because of the multi-valued character of this particular function. And here you will have, you can say that the function will be a multi-valued function with 2 branches. So here it will be a multi-valued function. Here also there will be a multi-valued function. Here you see this power is 1 over 3. So there will be 3 branches to this particular function at zeta is equals to, I think 1 upon minus, 1 upon iota, that is minus. Okay, so overall this particular function will also have branches. I'm not denying that, but I'm not interested here because I'm not interested in finding what sort of values does 1 over z take. Because 1 over z would be eventually z bar divided by mod z ka whole square. So this is not asked to me. To me, what is asked, what sort of values does z take? Okay, so this will indeed have 12 branches. So this will indeed have 12 different branches. So for a single point, let's say z1, if I place here, I will get 12 different values. Do you understand? See, after a while, 1 revolution, again 2 revolution, 3 revolution, 4 revolution, 5 revolution, and after z, after 12 revolution, you will come back to the very same point. After 12 revolution, you will come back to the very same point, the same value. देखो कल पढ़ा था हमने r raised to power 1 z की power 1/2. So you have r comma theta. So this was 0 revolution. When you came back after 1 revolution, you had value minus root over r e raised to power iota theta by 2. So you have two branches. After a second revolution, you again came back to the very same point, but the value now is same. Now you will have r raised to power 1/2 e raised to power iota theta. So after two revolutions, you get back to the same value. Similarly, if I take any sort of value like r comma theta, after 12 revolutions, I will come back to the same point. So there are 12 branches. For all these 12 branches, z1 will be some 1 over z1 also you can define. Let's say z1 is a non-zero number. And 1 upon z1 will be defined, and 1 upon z1 is nothing but some zeta. So there will be some different values of zeta also here. But I'm not interested here. I'm interested in this part. So there are 12 values for a particular z1. All those when multiplied with these will give me overall 12 different branches for entirely this function. So there are 12 different branches associated to the function fz. So I can say that there are 12 different values that this function can take. Are you getting my point?
हाँ भैया।
भरत को समझ में बेटा? पहले वो कंफ्यूजन हो गया था ना, पहले वो लोग z इक्वल टू, मैं सोच रहा था कि 0 होगा, बट 0 है ही नहीं. थोड़ा ध्यान से देखेंगे ना तो this will be a there will be a branch point at zeta equal to minus 1 upon r. Okay, and there may be a branch point here also. So if you write it in this fashion, let's say 1 minus zeta and 1 plus zeta. So this is 1 minus zeta and 1 plus zeta raised to power 1/2, and here also 1/2. So at zeta equal to plus minus 1, you have a double holding. Sorry, there is a this particular function is a multivalued function also. This particular function is a multivalued function. At z and zeta equal to plus minus 1, there are branch points. So branch points with two values possible. So there are this multi-valued character, or you can say that corresponding to zeta equal to 1, there are two branches. Corresponding to zeta equal to minus 1, there are again two branches. Corresponding to minus 1 upon zeta, minus iota also, there are three branches. But hardly it matters, because eventually what I'm saying, this particular function depends on 1 over z, not z. I'm supposed to find how many values does z take. So z take 12 values. All these 12 values, when multiplied with this, will give me 12 different values. So overall, this particular function will have 12 different values for a particular value of z. Am I clear?
Yes, sir.
So should I move ahead now? Okay. So yesterday, what we were doing, we were interested in finding the Taylor. We were interested in finding the radius of convergence of Taylor series. Okay. So if a Taylor series is been given to me, what I can do, yesterday I taught you something called as ratio test. What are you supposed to do? You can simply find limit n tends to infinity, an plus 1 upon an modulus is equal to 1 over r if the series is of this sort. Okay, and you can say that if at all my series is expanded about z naught, then I can say that my domain of convergence is mod z minus z naught less than r. Okay, I hope it is clear. Or you could do another way. You can simply use term by term this thing. The un plus 1 upon un mod should be less than 1. So this will give me what? Radius of convergence, and also give me domain of convergence. This is D'Alembert's ratio test. Okay. Now, yesterday I was doing a question where the lecture actually got cut. So let me do it all over again. So it was like n equal to 0 to infinity. Here it was 1 over n factorial. Here it was, I think, iota z minus 1 divided by 2 plus iota. And this was raised power n. So what to do? How to go about this particular function? You just take these all things common out. So I've taken all these things common out. So this will give me iota upon 2 plus iota raised to power n. 1 upon n factorial will come out. There would be a summation sign here. There would be n equal to 0 to infinity here. And here it will be z minus this entire thing. You just write this entire thing as some alpha. So this will be, okay, so you just write it as some. So if you just take all these things common out, iota upon 2 plus iota, so this will give me iota upon 2 plus iota upon iota, isn't it? So if you take this entire thing common out, you'll get this. Yes or no? So eventually I would write this as alpha. This is some alpha raised to power n, 1 upon n factorial. Here you have z minus some alpha raised to power minus 1 raised to power n. Okay, I hope it is clear. So how would you find the radius of convergence? So radius of convergence is limiting value n tends to infinity. You have modulus of an plus 1. So an plus 1 would give you an plus 1 divided by n plus 1 factorial, and this will give you upon an. So this is alpha raised to power n mod. Okay, this will get cancelled. So this is some alpha. Alpha ka mod will be what? So alpha is what? Alpha is, I think, iota upon 2 plus iota. इसका mod क्या होगा? It will be some 1 upon root over 5. ठीक है, इसका mod क्या था? Root over 2 का square plus 1 का square. ठीक है, so in any case this will be some constant. I'm not interested in this. This will give me what? 1 upon n plus 1. So limiting value n tends to infinity. This is some constant which I've already stated. This is n tends to infinity. Overall this term will go towards 0. It implies 1 over r is some 0. In extended real number system, I can write that r equals to infinity is the radius of convergence for this series. And where is this series centered? This series is centered at z naught is equals to 2 iota plus, minus 2 iota plus 1. So if you just multiply iota up both ऊपर या नीचे, तो आपको क्या मिलेगा? Iota ऊपर multiply किया, this will give you iota. ये हो जाएगा -1 और नीचे एक और माइनस आएगा. तो if you write 2 plus iota upon iota and multiply with iota and iota, you will get 2 iota minus 1 divided by iota ka square, again minus 1, this will give this. So your z naught is this. Okay, so this series is centered at this particular point with the radius infinity. So this particular series which is centered at z naught is equal to 1 comma minus 2 has the radius of convergence as infinity. Am I clear to you? ये चीज समझ में आई? So this particular series is convergent for entire finite complex. Yes or no? बढ़े आगे.
हाँ भाई.
Okay, so there are times where you will find that this particular formula is of lesser use, and there can be a better formula to find things. And in fact, in mathematics, we always say that root test is more powerful than the ratio test. Okay, so let us focus our attention to something called as root test. Let us focus our attention to something called as root test. So instead of finding ratio, what you're supposed to do, you're supposed to find the root of it. Okay, you are supposed to find root of it. So what does that test say? Let's say if I have a series summation, let's say an. If I have a series summation an, and how to judge whether this particular series is convergent? So this particular series is convergent if limit n tends to infinity, an ka mod raised to power 1 upon n, and write it as supremum. So this is limit supremum. Don't get confused with supremum. I will come over it. For most of the cases, you don't have to find the supremum, but there are cases where you have to find supremum. Supremum अभी के लिए ऐसा समझो अपर बाउंड. अभी के लिए ऐसा समझो अपर बाउंड, हालांकि ऐसा नहीं होता, इट इज लीस्ट अपर बाउंड. बट अभी के लिए जस्ट कीप दिस टर्म. अभी हम आएंगे व्हेन टू यूज एंड व्हेन नॉट टू यूज दिस. But overall, just you have to find an raised to power an की mod raised to power 1 over n. You just find this limiting value. If it comes out to be equals to L, and if L is less than 1, then this particular series given by summation an is convergent. Okay, so this is from series I'm teaching you. Okay, यहां तक समझ में है? ये ऊपर से चला गया. चलेगा बच्चे सारे समझ में आई बात. Or you can also write, if you are supposed to find what is your 1 over r, so you can write 1 over r as limit n tends to infinity an supremum of this. So this particular thing will give you radius of convergence also. So if you want to find the radius of convergence for a series given by an zn summation, then you can simply write this formula and you will be able to get the radius of convergence. And you can write that my series is convergent. Let's say this series is centered at 0. My series is convergent for this. I'll explain you with certain questions. ठीक है, डरो मत, इस आगे बढ़े. So कहाँ पर it will become very indispensable for us to not to actually use this only. I'll come to those questions only. Okay, यहाँ तक समझ में आई बात? कहाँ चले गए सारे बच्चे? बताओ, यहाँ तक समझ में आई? कोई कुछ बोलता भी नहीं है।
Yes, sir.
Okay, so let us take an example to understand the same. Okay, so let us take this example. 1 plus 2 by n raised power n square zn and summation. So for example, in this series, not n नहीं दे रखा आपको, n square दे रखा। और थोड़ा सा अगर बचपन का याद हो, नहीं याद हो, तो मैं यहाँ लिख देता हूँ। 1 plus lambda by n raised to power 1 over n की लिमिट, where does it go? It goes to e raised to power lambda. Okay, or if I write in this fashion, not 1 over n, ठीक है, x tends to 0, this will give me e lambda, e raised to power lambda. So you remember these formulas. Okay, so as n tends to infinity, अगर ये बहुत छोटा हो रहा है, देखो कितनी, see the beauty of mathematics. You say 1 को मैं कितनी बार मल्टीप्लाई करूं, इन्फिनिट टाइम भी मल्टीप्लाई करूं तो आंसर 1 ही आना है। ओके, मतलब एज लार्ज एज पॉसिबल। अब ये मत कह देना सर हमने 1 की पावर इंफिनिटी को तो इनडिटर्मिनेट पढ़ा था। दैट इज नॉट व्हाट आई एम सेइंग। दीज आर फॉर्म्स। फॉर्म्स मतलब समझ रहे हो, जब लिमिट निकालने की कोशिश करते हैं हम ये देखते हैं कि 1 के ऊपर पावर क्या चल रही है। तो लेट्स से कोई कहता है कि ऐसा कोई फंक्शन है जो नीचे तो 1 हो रहा है और यहाँ तो 1 हो रहा है और यहाँ इंफिनिटी पे जा रहा है, तो हम उसको 1 की पावर इंफिनिटी बोल देते हैं। बाकी अदरवाइज ऑलवेज, और फिर हम कहते हैं इट इज इनडिटर्मिनेट। उसका मतलब क्या होता है मैं बता रहा हूँ, दैट इज व्हाट आई एम ट्राइंग टू एक्सप्लेन। सो अगर 1 को तुम इनफाइनाइट टाइम भी मल्टीप्लाई करो, लाइक यू कैन मल्टीप्लाई इट इन एनी नंबर ऑफ टाइम्स, आंसर हमेशा 1 ही आना। बट 1 की तरफ जा रही है क्वांटिटी और उसके ऊपर पावर चढ़ रही इनफिनिट, इट कैन गो एनीवेयर। सो देयरफॉर देखना बुक्स में तुम्हें मिलेगा 1 की पावर इनफिनिटी इज इनडिटर्मिनेट। Let's say, just take this example. So I'm saying, let's say 1 plus lambda upon n की पावर n, लिमिट n टेंस टू इंफिनिटी। अब थोड़ा सोचना है इस पे। देखो n टेंस टू इंफिनिटी पे ये ओवरऑल नंबर कहाँ जा रहा है, 0 पे। तो लगता है सर ये पूरा नंबर 1 है, 1 की तरफ जा रहा है, 1 की तरफ जा रहा है, टेंडिंग टुवर्ड्स 1 आई एम सेइंग। And this particular quantity is tending towards infinity, yes or no? This is only tendency. I'm not writing it as 1 raised to power infinity. This is form. बुक्स में ऐसा बोला जाएगा, दिस फॉर्म corresponds to 1 raised to power infinity, मतलब this particular the base has a tendency to move towards 1 and this particular exponent has a tendency to move towards infinity, so I write it as 1 raised to power infinity. तो अब देखते हैं क्या हो रहा है। मन में क्या लग रहा है कि हाँ यार 1 के पास कोई राशि है या 1 के पास कोई क्वांटिटी है, that is getting multiplied infinite number of times. So what does your heart say? Your heart says okay, 1 would be an answer to this. But eventually what you find, answer is e raised to power lambda. See the beauty of mathematics. So if I'm saying 1 upon 1 by x raised to power x and limit x tends to infinity, what does your heart say? Your heart says, okay, this will tend towards 0. This will be some very infinite powers. What stops me from writing it as 1? So 1 is, it is tending towards 1. This is tending towards infinity. I would say, okay, it is equal to writing 1 infinite number of times, and why not it is 1? It cannot be equal to 1. The very definition of e raised to power x, you just open this up and you will be able to find that this is nothing but a power series of e raised to power x. Okay, so eventually you'll find that this particular series goes towards e raised to power lambda. This particular limit goes towards e raised to power lambda. I'm sorry. So why not execute this by kind of thing? So you have this kind of structure 2 by n. You have a structure n square. So there's a big problem with this. This is n square. This is not n. Okay. Further, also, if you'll see that if I take n plus 1 here, n plus 1 here, this will become n square plus 2n plus 1. Here it will become n plus 1. And if you just try to divide it by an, that is 1 by 2 by n raised to power n square, it will become very difficult for you to assess anything from ratio test. And I've already stated that root test is more powerful than ratio test. That is, it may be possible that ratio test fails at a point, but root test doesn't. So overall, when such structures are given, like not n or some powers of n square, it would be very wise to use root test. So let us use root test. So let us first find uh, whether this particular series is convergent. So let us first find radius of convergence. So let us first find radius of convergence. So what would be radius of convergence? Limit n tends to infinity, 1 plus, this is 1 over r, 1 plus 2 by n raised power n square की whole power 1 over n. Okay, so this will give you limit n tends to, and in fact this will be some supremum limit. However, यहाँ पे supremum की जरूरत नहीं है. That is why I'm just writing n tends to infinity. I'll tell you where it is required, so don't worry about it. Okay, so 1 plus 2 by n. This will give you raised power n. This is towards e square. N, this is lambda. You just find e raised to power lambda is e square. So what is the radius of convergence? So radius of convergence would be e raised to power minus 2. Okay. So where this series would converge? This series would converge for mod z minus 0 less than r. R is e raised to power minus 2. Are you getting my point till now?
सर ये लिमिट की वैल्यू e टू द पावर लैम्डा ये कैसे पता चलेगी?
This you have to remember. Otherwise, ये याद कर लो. This is a formula from your standard 12. So you just remember this formula. So, I won't be able to derive it all. So you just try to remember this. Okay, ये formula याद कर लो. Okay, certain standard limits, you just remember them. Not in general for the sake of examination, I'm saying, for the sake of your entire physics also, I'm saying, because then it is like equivalent to studying mathematics. So if you really want to do an exercise, you try to expand it in binomial series, this thing, in binomial expansion, and you'll be able to somehow see that this converges towards e, or so e raised to lambda. So that would be a very tedious exercise to do right now. So just remember this formula. Okay. Now let us move further. Or otherwise, what you could have done? अगर ऐसे नहीं करना, ऐसे भी कर सकते. You just write limit. I told you this series converges only if this mod raised to power 1 upon n is some l and l is less than 1. You simply write 1 plus 2 upon n square, keep power, sorry, n keep power n square, and here it is given z is to 5. So what you are left with, limit n tends to infinity, 1 plus 2 upon n, and this 1 upon n gets cancelled, so you'll get you will get n, and here you'll get mod z less than 1. And this entire limit, right now, I've told you this entire limit would come out to be e raised to 2. So you'll get mod z less than 1 upon e square. तो चाहे तुम ऐसे करो, term wise करो, that is simply write term का mod, you write term का mod, this an का mod 1 by n less than 1 करो, तो भी काम चल जाएगा. और ये सिर्फ आगे कोफिशिएंट का mod less than 1 करके आप 1 upon r से equate करके you can write in this fashion also, you can write in this fashion, the answers will be same. Are you getting my point? कि ऊपर से चला गया. देखो, there are two ways. Again, let me tell you, there are two ways. Let's say if I have a function fz is equals to, let's say if I have a function whose power series representation is this, is in this fashion, you can go in two ways. You can either take root test or you can take ratio test. In order to find ratio test, तुम कहोगे कि my series converges in certain radius of convergence, and this radius of convergence is r. So mod z minus z naught is less than r, where my series is convergent. So you can find formula for r would be 1 over r limit n tends to infinity an plus 1 upon an का mod. या तो ऐसे कर लो, और एक काम करो, इस पूरे को डिवाइड कर दो. लेट्स से दिस इज योर टर्म tn, तो सिंपली क्या करो, लिमिट tn का tn plus 1 upon tn का mod पूरे को लेस देन 1 लिख दो. यू विल कम टू द सेम आंसर. Here you will get domain of convergence, सीधे मिल जाएगी तुम्हें domain of convergence, and whatever is written on the right hand side becomes your radius of convergence. In root test, you can go again into fashion. You can first find radius of convergence by doing this formula, limit supremum, an mod raised to power 1 over n. You can find this, and then write that my series converges for mod z minus z not less than r, or you can go by writing limit n tends to infinity tn ka mod ki power 1 over n is less than. Both will give you the same answer. The choice is entirely yours. Okay, so I hope to meet you in the next session, and this is what I'm leaving you with. Any doubt, difficulties till now, do let me know.